Hi, my name is Ben Baca, and I'm owner of National Design Build Services. We are a national heating and air conditioning contractor that actually does most of ARCO's work. So we do HVAC design, and today I'm going to be talking about different types of HVAC systems. Introduction into HVAC systems. Basic HVAC equipment, you've got fans and blowers, furnaces and heating units, filters, compressors, condensing units, chillers, evaporators, which would be the cooling coil, and your typical air distribution system. So typical system types and common terms we use in the industry. Basically, you've got your package rooftop units, which is more typical on office buildings and what you guys typically use. You've got split systems, which are more for residential type use, which you would see in your house. You've also got ductless split systems, which can be used for smaller rooms, computer rooms, and you've got crack units, which are specifically computer room split systems. You've got package terminal air conditioners, which are also referred to as PTACs. And then with respect to your different types of systems and uses, you have constant volume systems, VAV systems, VVT systems, which stands for variable volume and variable temperature, and then DX, which is direct expansion, heat pumps, hydronic, which would be water side systems, and then HVLS fans. So package rooftop units, this is just a picture, and this is what you would see in your typical office building. Basically, a package rooftop unit combines all of your different components of your HVAC system. So you've got your condenser coil, your evaporator, your compressor, and your expansion valve all packaged within that piece of equipment. And typically you're sitting on a roof. You can also sit on the side of a building and duct with side discharge into the building. So PTAC is just as shown here. You've got a package terminal air conditioning unit, and it's basically just a small unit that you could use for a single room inside a house. Split system is what you would typically see in your residential home. You've got two different components, which would be your inside furnace, which has your evaporator coil as well. It's got your heating component, and then you duct to all of the distribution and grills within your home. The outside component, which is connected with refrigerant piping from the evaporator coil to the condensing unit, that sits outdoors, and that acts as your condenser. So examples of ductless split systems, you could have your condensing units outside, and then you've got a ceiling cassette, which would be shown on the left, and then you've also got a ductless split that would just hang on a wall. Your crack units, which are referred to as your computer room air conditioning systems. Typically, you would have a raised floor within a computer room, and then you would discharge cold air into the floor, and then the cold air would be discharged through grills in the floor, and the hot air rise to the ceiling and into the ceiling plenum and back to the crack unit. Warehouse ventilation systems, typical for would be an upblast fan, which is shown on the left, and then you've got your combination louver damper on the right. So your louver dampers would actually be installed in the concrete tilt walls, and your roof-mounted exhaust fans would be shown on the roof. Warehouse HVLS fans, they're typically indoors and used for destratification. Hot air always rises, so in essence, you're trying to get heat back to the floor in the wintertime. And in the summertime, it provides high velocity air, which keeps building occupants cooler. Your single zone systems are basically served from a packaged rooftop unit or a split system, but basically they might serve multiple rooms within a facility. And your single zones are typically your cheapest, less comfortable, but it's usually what's used within warehouse office spaces. So you're going to have a lot of hot and cold people depending upon where you're at within the facility. Your VVT system is typically a step up from a single zone unit. And basically the way that a VVT system works is it's variable volume and variable temperature. So you actually supply air from your supply fan, and you've got dampers for each zone that open or close based upon a call for heating or cooling. So typically these zones would actually call and pull the zones depending upon if 2 out of 3 wanted cooling. It would send the rooftop unit into cooling mode, and then the zone that needed heating would actually start to back off the damper. And as pressure starts to build up within the duct system, you have a bypass damper that starts to open, and that air that would have been going to the zone for heating now actually starts to back up and goes back through the bypass damper back into the return air. So the same could be for heating. If you would have 2 out of the 3 zones calling for heating, basically you'd have one zone maybe calling for cooling, and so the rooftop unit would go into a heating mode, and the zone calling for cooling would actually close off the damper to not be providing warm air to that zone, which would overheat the zone. So a VVT system is usually a step up from a single zone system. However, it's typically referred to as the poor man's VAV system, which we'll get into. So a VAV system is similar to the VVT system, except a VAV system continually delivers 55 to 60 degree air. So it's always conditioned, and it blows it down the duct stream, and you've got terminal units similar to a VVT system, which have reheat coils in them. So the box will open and close based upon a call for heating or cooling, and if it's for cooling, the heating coil will remain off. If it's for heating, the zone damper would go down to a minimum, and then it would reheat the air from 55 or 60 degrees up to 90 degrees to maintain space temperature set points. So these are typically energy saving features. You would, as those dampers back off, instead of similar to a VVT system where you would go and back up and bypass damper, you would, as the dampers start to close off, the pressure inside the ductwork starts to build up, and then your fan ramps down with a VFD. So your fan basically modulates off of duct pressure based upon what the zone dampers are doing within the system. Hydronic systems typically aren't used except on larger buildings. A lot of times pharmaceutical facilities, you'll have hydronic systems, which are really just chill water systems. So you got pumps, piping, and valves within these systems, less typical from what you guys do from a daily basis. Major hydronic equipment that would be used in those systems would be the chillers, boilers, cooling towers. So your chillers would produce cold water, which would be sent to indoor air handlers, referred to as split systems. Your boilers would produce hot water, which would be for hot water heating and reheat terminals. And then cooling towers would act as similar to a condenser.